So our last video discussed multiplication. In our last video, we saw that it actually was not repeated addition. So we thought about multiplication in a way that's maybe new for some of you. It turned out that multiplication by a positive number was a stretching or a shrinking, a scaling. Multiplication by a negative number rotates pi radians, that's 180 degrees, and we always rotate counterclockwise. If you multiply by I, then you're rotating 90 degrees or pi over 2 radians and going in the complex direction. So the main question I'd like to answer in this video, and it has an amazing, surprising answer if you've never seen this before, is what should you multiply by if you want to rotate theta radians? So I know what to do for pi. I know what to do for pi over 2. What about an arbitrary angle? How do I rotate theta radians? Well, I drew a picture down here. This is my complex plane. I got the real axis over here. I got the complex axis up here. And I drew a stick of length 1. And I want to rotate that stick theta radians. So this length of the stick is 1. This length is 1. I could draw a perpendicular coming down. And if I do that, then using basic trigonometry, I could find this length to be cosine theta, and I could find this length to be sine theta. That's basic right triangle trigonometry. So that means this complex number that I'm landing at right here should be cosine units in the real direction, so cosine theta, and then I go sine theta units in the I direction, so plus I sine theta. So the answer is you need to multiply by cosine theta plus I sine theta. Because if I start with 1, I want to land here. So the way to get this number is to multiply this number times 1. So that's my answer. I'm going to multiply by cosine theta plus I sine theta. However, you may recognize this. You may recognize this using Euler's formula. This is the same as e to the I theta. So the surprising answer, if you multiply a number by e to the I theta, then you're actually rotating theta radians. So let's do an example. What is the square root of 2? Well, actually, let me write it in the reverse order. Let me write it as e to the I times 3 pi over 4 times the square root of 2. So what I do for this is I start with square root of 2. So I start with a stick of length square root 2. So there's my real axis. There is square root of 2. Let me do it in red. So there is square root of 2. Then I'm going to rotate counterclockwise 3 pi over 4 radians. So that's 3/4 of the way of a 180 degree turn. So here I would land. So this would be rotating 3 pi over 4 radians, and I'd end up right here. The length of the stick is still the square root of 2. This just rotates. It doesn't shrink or compress. If I wanted to shrink or compress, I'd multiply by a positive number. But I'm over here. That is a new stick of length 2. That means I have a side lengths of 1 and 1 to get the hypotenuse to have length 2. In other words, I ended up with the complex number -1 in the real axis and 1 in the complex axis. So there, that's the answer to this problem. Okay, hopefully I've taught you something new about multiplication.